Like I said in the last video, we're going to be building off of our ideas of converting from moles of one substance to moles of another substance. And now we want to convert from grams of one substance to grams of another substance. Okay, so I mentioned this term stoichiometry before. It's just a relationship among substances involved in chemical reaction. And it comes from this balanced chemical equations, where it's really critical that we know how to balance equations well. So a stoichiometry problem then, when you're in the homework or a test or a quiz, is really asking you how much or how many of a substance do we have, okay, or particles do we have. And so what you're going to need to know to be good at doing these stoichiometry problems, they're going to build off of a lot of what we've already learned. You're going to need to know how to write chemical formulas, okay? You're going to need to know how to calculate the molar mass for those chemical formulas, use the molar mass to convert to moles, right? If you're given grams of a substance, write balanced chemical equations, and then use those equations to convert from moles of one species to moles of another species, which is the video that we just went through. So through all of these, I think my list here is accurate. If not, you can reach out to me and let me know if these sections are wrong. But these are all things that we talked about in the last few chapters. So if you're having trouble with any of these concepts, go back and review those concepts because they're going to be really important here and moving forward in this chapter. Okay, so this is just kind of a big chart that you can use as kind of a way to process through these problems. But let's say you're given grams of a reactant, right? So, and you want grams of a product, let's say over here. So our steps that we're going to take, and we're going to do plenty of examples together, so this will be clear, is you want to convert grams to moles by using the molar mass of the compound. And then you can use the mole ratio, like we did in the last video, to convert from moles of one thing, in this case, the reactants, to moles of the products. And then once you're here, you can use the molar mass of the products, or the product, I should say, to convert to grams of that particular product, okay? And you can also, of course, if you're given Avogadro's number, you can convert particles or molecules to moles and then do the whole process that way, kind of going the other way, okay? So the general strategy is on the bottom. You go from a measured quantity, which is like the grams you'd measure on a balance. You go to the particular level, you convert it to moles, right? Use the molar ratio. They go from moles of one thing to moles of another thing. And then finally, you can convert to grams. Again, another measured quantity, something you can measure in the laboratory. And we'll see that a little bit when we talk about percent yields, not in this video, but in next week's video on this chapter. Okay, so like I said, this is just a flow chart that you can come back to and look at and try to understand as we're doing these problems or rationale through it. If it helps you, great. If it doesn't, ignore it. Okay. So here's it without the chart. The stoichiometry path. Change the mass of a given species to moles, step one. Step two is change the moles of a given species to the moles of a wanted species, and then change the moles of the wanted species to mass, okay? These are the three steps we're gonna do when we wanna convert mass of one substance to mass of another substance. Okay, let's just do plenty of examples. I think there's 4 or 5 examples that we're going to be doing either in this video or we'll split it up into 2 videos. But let's see here. How many grams of carbon dioxide are produced when 10 grams of methane is burned? Okay, so first thing you want to do is write down and balance the chemical equation, because balancing it is the key. If not, you'll get the ratios wrong. So CH4, or methane, 2O2. I'm just going to write down the equation. Oh, okay. So that is my chemical equation balanced. Again, we're going to write down what's given. Okay. 10 grams CH4. Oh. And we want, okay, grams CO2. Okay, so here's our path. Here's what we're going to do. I'm just going to change color here. So again, it's a dimensional analysis problem that we're setting up. So the path, all right, we're going to go from 10.0 grams of methane to moles of methane. Remember, we're going to go grams per moles. We're going to use the molar mass here for that of methane. Then we're going to go from that to moles of CO2. And then we're going to go to grams of CO2. Okay? And we're going to do that by the molar mass again. And in between is the molar ratio to go from moles of one thing to moles of another thing. Okay, so what we're going to do here, we're going to, I might run out of room actually, but you would calculate the molar mass of both substances. Okay, so the molar mass of CH4, let me just give myself a little box here. Okay, so we have carbon, 12, hydrogen, 4 times 1. Okay, so this is 16 about. Okay, and then the molar mass of CO2, okay, C, we have 12. Oxygen is 16 times 2. This is 44. Okay, about grams per mole. Grams per mole. Okay, grams per mole. Okay, sorry if that is a little sloppy. I'm trying to fit everything. Okay, so those are these guys right here, the molar masses of these substances. Okay, so let's write out our equation here. Okay, so we have 10.0 grams of, you know what I'm going to do? So actually, let's hold that thought. Okay, let's pause for a second. Write down these molar masses of these compounds, and I'm going to erase it so I have some more room to work here. Okay, so it's about 16 grams per mole for methane and 44 grams per mole for carbon dioxide. Okay, so just keep that in the back of your mind. So I'm just going to erase this. All right, because that's going to give us a lot more room here, and it's not going to look so crowded. Okay, and I'm going to change the color too. Okay, so here we go. So 10.0 grams of methane. And the way we convert, okay, to moles of methane is with the molar mass that I just erased, okay? But you wrote it down, grams, okay? All right. And then here now, notice that the units of grams of methane cancel with grams of methane. So I want to cancel out now the units of moles of methane. So to convert from moles of one thing to moles of another, right? I want to use the molar ratio right here. We're at this step right here, okay? So from my equation, for every 1 mole of methane, okay, there is also 1 mole of carbon dioxide, okay, from my balanced chemical equation. And again, now the units of moles of methane cancel out with the units of moles of methane. So I'm at moles of carbon dioxide. Okay, so now to convert to grams of carbon dioxide, I know for every 1 mole of CO2, there's 44 about grams of CO2. You might have a slightly different number. I just kind of rounded it so it would fit on the screen, okay? And again, now moles of CO2 cancel with moles of CO2, and we're left, our final unit is grams of CO2, which is what we wanted, right? So we know we did this correctly. At least we set it up correctly. Okay, so when you put all this in your calculator, I get a number 27.4 grams of CO2. Okay, and I'll just double check that actually in my calculator and let you kind of double check it with me. Okay, 16 times 44 equals 27.5 actually is what I get when I just put these numbers in. I think it's because my other numbers were a little different, but that's okay. I mean, it's in the same ballpark, okay? So there you go. This is how we convert from grams of one thing to grams of another thing. This is the general structure of these problems. So let's do a lot more, okay? So it's pretty clear. So here's another example. Calculate the number of grams of O2 that is required to burn 155 grams of ethane in the reaction. So in this case, it gave us the reaction. Okay, so again, write down what's given, 155 grams of C2H6, okay? I want grams O2, okay? So my path here, I'm gonna go 155 grams C2H6, okay? 2 moles C2H6 ethane, 2 moles of O2, 2 grams of O2. Okay, so why don't we do this step for step now? Okay, so changing my color. So again, I'll start over here a little bit so we have some more room. 155 grams of C2H6 of ethane. Now, if I want to go to moles of ethane, in this step, I need the molar mass of ethane. Okay, so for every 1 mole of my 2H6, my pen was taken off on me for some reason. Oh, that's because I have a mouse plugged in on the other side here. Okay, no wonder. My arm is like pushing my mouse away. Okay, so 1 mole of C2H6 of ethane, we need the molar mass. So I'll let you calculate that actually, and I'll just write it down here. Okay, so it's 12, okay, really 12.01, I guess, to be more precise. 6 times 1.01, okay. You add that together, and I get 30.08 grams C2H6. Okay. So again, just looking at our units, grams of ethane canceled with grams of ethane. Now I'm at moles of ethane. Okay, so to convert from moles of ethane to moles of oxygen, I use the molar ratio, which is given from the chemical formula shown up top. So from that formula, there are let me change my color back here. Hold on. There's 2 moles of ethane for 7 moles of oxygen, okay? And now again, moles of ethane cancel out with moles of ethane. I'm at moles of oxygen, and I want to convert to grams of oxygen. So I use the molar mass. So for every 1 mole of oxygen, there's oxygen. Well, that's 16 times 2. Okay, so 32 grams per mole. Okay, so this is 32 grams. Really 0.00. Okay, so when you plug all that into your calculator, what you should get is 577 grams of oxygen. Okay, and again, that's the unit we're left with because moles of O2 canceled out, and we're left with grams of O2. Actually, I should have wrote the O2 there. Okay, so this is our final answer, 155 grams of oxygen. All right, so hopefully the structure of how we're going to do these problems is making sense. I'm going to probably stop here for this video, but we're going to do, I think, 3 more examples in the next video. So I will see you there.